So today we're going to cover section 3, and now what we're going to do is, instead of trying to prove that these angle pairs are congruent, we're going to prove that the lines are parallel. So pretty much what we're going to do today is undo or do the reverse of 3-2, and we're going to be finding the converses of the theorems and the postulate we learned yesterday. So we're going to be flip-flopping this statement. So the first one is called the corresponding angles converse postulate. So yesterday it was the corresponding angles postulate. Today it's the converse. So what the converse states is if two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So yesterday, when we learned it as just the corresponding angles postulate, the statement said if two lines are parallel, then corresponding angles are congruent. So now it's been flip-flopped. So for this statement, we could say that if angle 2 is congruent to angle 6, then lines J and K are parallel, and this would be the corresponding angles converse postulate. That's what we're using to prove the lines parallel. So for each one of the theorems and this one postulate that we learned yesterday, we're going to learn a converse today. So yesterday we learned how to prove them congruent or a supplement. Today we're going to learn how, if they're given to us as congruent or a pair of supplements, we can prove lines parallel. Next converse we're going to learn is we have one for alternate interior angles converse and the alternate exterior angles converse. So again, they're both very similar. They both start out with if two lines are cut by a transversal. The only difference is the first one is an alternate interior angles are congruent, then the lines are parallel. The second one, if two lines are cut by transversal and alternate exterior angles are congruent, then the lines are parallel. So I'm going to give you a figure. So let's say I draw my two parallel lines, or two lines. We don't know if they're parallel yet. And let's call them P and Q. Drawing a transversal, and I'm going to number the angles 1, 2, 3, 4, 5, 6, 7, 8. So here, if I have two of my angles that are marked, say 3 and 6, with congruency marks, and if I'm asked to prove that line P is parallel to Q, the way that I could prove that P is parallel to Q is I could state that if angle 3 is congruent to angle 6, then line P is parallel to Q. And this reason would be the alternate interior angles converse. Let's say that I have angles 2 and 8 with markings showing that they're congruent. And if I were asked to find out if P and Q are parallel, again, I could state that if angle 2 is congruent to angle 8, then line P is parallel to Q. And that would be your alternate exterior angles converse. So for the converses, what we're proving are that the lines are parallel. Next theorem is the consecutive interior angles converse. Again, you might have remembered this as same side interior. So the same side interior or the consecutive interior angles converse states that if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So again, I'll draw you a figure. I've got two lines here. We'll call them M and N. Draw in my transversal. And let me just label my interior angles here. 1, 2, 3, 4. So here, let's say in my picture, I told you that angle 2 was 60 and angle 3 was 120. Because I could show that angle 2 and 3 together, when I add them equal 180, I could show that these are supplements. So I could say if angle 2 and angle 3 are supplements, then line M is parallel to line N. So I would need to show that they're supplements, not that they're congruent, to use the consecutive interior angles converse. This is called the transitive property of parallel lines. So this says if two lines are parallel to the same line, then they are parallel to each other. So let's say I draw 3 lines here. We'll call them J, K, and L. So if I state that if J is parallel to K and K parallel to L, then J is parallel to L. So what that's stating to me is saying that if J is parallel to K, and then if K, I'm doing a different color here, K is parallel to L, I can cut out the middleman. See where there's 2 lines here? I could jump and say, by the transitive property of parallel lines, that J is also parallel to L. See how the K's cancel each other? So if you're going to use this in a proof, you must include that you're using the property of parallel lines. Yes? No, you'd have to show transitive here for the parallels. Parallel. This is going to be big time for you. These are going to be the 5 ways that you can prove that 2 lines are parallel. This should be a big hint that you're going to be trying to find either a pair of corresponding angles that are congruent, a pair of alternate interior congruent, same side that are supplement, same side interior, or show that both lines are perpendicular to a third line, or that both lines are parallel to a third line. These will be the 5 ways that you're going to be doing in your proofs to prove that lines are parallel. Again, this same side interior, you could also call it the consecutive interior.
Do you have to do all 5?
No, you pick one. So you'll be choosing one based on your given and build your proof from there. So let's go ahead and see if we can figure out which segments, either AC, AD, BE, BF, are the parallel segments here. So at first glance, I don't see any congruent angles. But what if I took away, say, this separation and added these 2 angles and made this one big angle? So 24 plus 36 is what? 60, right? And then if I merge these 2 together and do my angle addition, 22 plus 38 is also 60. Now, notice how I just made those 2 angles. So see how I traced around CA and this one and then B. Now, the side that they both have in common, see this one here, how it has it here and here? This is going to be my transversal. And then the other side of your angles, these are going to be the parallel lines. So because I can find two corresponding angles that are congruent, I could say that AC is parallel to BE, and my reason would be the corresponding angles theorem converse, or converse theorem. You got to have the word converse in here. So the corresponding angles converse. I can prove the lines parallel because I found a pair of corresponding angles that were congruent. Let's try the next one. What value of x makes AB, let's go ahead and highlight this, AB parallel to CD? So you can see you have right here the little right angle. And then if we wanted to figure out what would make them corresponding angles that are congruent, what would be my value of x? Notice this one's 90, so I need to know that x plus 40 also equals 90. So you can see that x is going to be 50. And the reason for this is if corresponding angles are congruent, then the lines are parallel. Another example. Example 3. Find the values of x and y. That will make J and K parallel. So they want us to find what makes J and K parallel, and also what makes L and T parallel. So again, I got a lot going on here. So I may need to look at things one at a time. So first thing I'm going to do is erase this transversal, or this parallel line pair. I'm going to deal with the two red parallel lines, and the gray one would be my transversal. So I can see that angle 60 along with 2y. These are going to be alternate interior angles, and I know that alternate interior angles are congruent. So I could say that 2y equals 60, divide by 2, and y equals 30. So this whole angle is 60, but y equals 30. Now, to bring in the information with 3x, I'm now going to use, let me take away this red line. And now what I'll do is show that this line and this line, and then I can see that 60 along with the 3x are going to be corresponding. And again, corresponding angles are congruent. So 3x is equal to 60, divide by 3, and x equals 20. So again, you're going to probably have to cover things up, turn your paper, just so you can see, and you may need to cover up part of it to answer one part of the question and cover up a different part to answer another part. We have one last slide. It's an application pattern. So it says, how can you tell whether the sides of the pattern are parallel in the photo of a diamondback snake? So they've taken this circular piece of the picture and enlarged it. So here is my enlargement. And again, we've got our red lines here. They want to know how we could prove that these are parallel. And then we have a transversal. What kind of angles are these two? Okay, what do we know about alternate interior angles? So if I have a pair of congruent alternate interior angles, then I could prove that the lines are parallel by the alternate interior angles converse. So I can tell that, yes, they are parallel. And my reason would be if the alternate interior angles are congruent, then the lines would be parallel or are parallel. You could have also said alternate interior angles converse. Either way, either write it out or tell me which one you would use. So your homework is the 3-3. Tomorrow when you come in, you're gonna work on the 3-3 warm-up, and then we'll go over the homework, and then I have a classwork assignment that you're gonna work on to get you ready for the quiz. I'm gonna be posting a bunch of review material in the module that you can use to start studying. I'm gonna give you some worksheets that'll help you practice proofs and all this other finding missing angle measures and naming them. So I'm gonna be posting a bunch of review material for you to get you ready for Thursday's quiz.